Krypton level 4 to level 5. So in the last episode, we got the password to this level 4 by using some frequency analysis on the monoalphabetic cipher. So now we're going to be shifting from monoalphabetic ciphers to polyalphabetic ciphers. So what polyalphabetic ciphers is, what this says is P may map to many or all possible ciphertext characters. So before, what we were working with is whenever we put our plaintext into our magic encryption thing and we spit out a ciphertext, it was always one-to-one mapping. So one letter would always map to another letter in ciphertext. In a polyalphabetic cipher, this isn't always the case. So one letter in plaintext may map to multiple letters of ciphertext depending on what the key is. So let's go ahead and take a look at this. So we're looking at a vignere cipher. So what that means is we have a key, and the key is a word. So for example, the word gold is our key in this example that they give on the website. In this example as well, our plaintext is proceed meeting as agreed. So what we do in a vignere cipher is we have our plaintext, so P, plaintext is proceed meeting as agreed, and our key, which is just repeated for the length of the plaintext. So we have gold just repeating multiple times until it reaches the end of the plaintext. And all we have to do is just add the two indexes, and that's what we get to our ciphertext. So P, for example, is 15, G is 6, and that's going to add up to 21. So that's just where it falls in the alphabet, and A is going to be, it's going to be 0 based, so A is 0, B is 1, C is 2, and so on. So G is the 6th letter if A is 0, so that's what we get here, and P is 15. If you want to count that out, go ahead. And that's going to equal 21, which is going to map to the letter V. So this is going to be our ciphertext spit out into actual form here. So let's go ahead and hop into our SSH and see what we have to do. So in here, we'll do /cd /Krypton, /Krypton 4, and we'll go ahead and look in here. So we have two found messages of ciphertext, as well as the message that we need to decode. So let's go ahead and take a look at this. So Krypton 5, so it's pretty small. So this should be our password here. So we'll have to use these found 1s and found 2 to be able to find that key. So we're going to need to know what this key is here, the letter, or the word rather, and then we'll be able to use that on our encrypted text to be able to go to our decoded plain text. So how do we want to go about doing this? So the plan is going to be to use these found messages. Let's go ahead and take a look at one. This is pretty long, in groups of 5 like we saw last time, to be able to use these found messages to somehow be able to crack what the key word is. So once we find that key word, it'll be a pretty easy process to decode that encrypted message and get our plaintext password for the next level. So let's go ahead and show off some scripts that we have. So the main idea of how we want to go ahead and break this down is if we can get this to somehow, we can't do frequency analysis right now, because if we wanted to do frequency analysis, it wouldn't really work because things can map to multiple different letters. So if we found out that there's like a ton of E's in the ciphertext, well, we don't know what that maps back to because it could map to a variety of things, or it could be mapped from a variety of things, depending on the placement. So for example, see, we have an R here, which maps to the key O, which is going to map to the letter 5, which is F, but we have an R here as well in the plain text, but it maps to a different part of the word, so it's going to spit out something different, and that's why it's polyalphabetic. However, we do know the key length, so it says here we know the key length. So if we can get every 4th letter, because the key length here in this example is 4, then it will be a monoalphabetic cipher again in that section of text. So for example, this P, E, another E here, and another N, all map to G. So if they're all mapping to the same letter, then it becomes monoalphabetic again. So if we can take this big found message, oops, wrong one, cat found one. If we can take this big found message and take every, let's see what the key length is, 6. So that we know the key length in this exercise is 6. So if we can take every 6th letter of this message, then it should be monoalphabetic. And we could shift that by whatever our starting number is. We can start at the 1st letter and go every 6, and then we can start at the 2nd letter and go every 6, and then the 3rd letter and go every 6. And then we'll have these messages to be able to take apart and find out what the letter is that we're decoding for that specific place in the key. And then we put all that together, and we'll get our total key. So I've got a couple Python scripts that I've made to be able to help us with this exercise. So the first one that I want to show you guys is this vignere shift. It's a little bit shorter than our frequency analysis. This is the exact same one that we used in the last episode. In this one, all the script does is it takes every, like I just explained, every how often you specify the key length in the arguments, and then the shift amount, which is an optional. If you leave it blank, it's just going to default to 0. And all it's going to do is it's going to take that file that you input to it and just take every, say the key length is 6, every 6th letter, and it will spit out some output. So all of this here is doing is it's just reading in the arguments, making sure those are okay. Then it's reading in the file, and then this is the actual meat and potatoes of what the script does, and it's just going to go take the index and mod that by the key length. Oops. And then if that's equal to the shift, which is how much we're shifting. So if shift is 0, then we're going to start at the first letter and go on. If the shift is 1, then we're going to start at the second letter and go from there. And it's going to take every however many the key length is letters from there and put that into the output. So let's go ahead and see this in action. So I want to SCP these 3 files here onto, I'll explain what this does when we actually get to it. It's a little bit shorter. And SCP this onto our terminal window, or our SSH rather. So let's go ahead and make a directory, or a temporary directory, so mktemp-tac d, and we'll cd on into there. So let's copy this, we'll cd in. And now let's go ahead over to our actual native host, and we have these files here. So let's go ahead and do our SCP. So SCP tac capital P 2231 is our port, and then we did this in the last episodes of Krypton 4 at Krypton. Oh, I need to specify the file first. So let's do vignere shift.py, and then Krypton 4 at krypton.labs.overthewire.org, and then our root, or our location is going to be that TMP. And we'll need the password from the last episode. I'll go ahead and enter that in, and it will upload. So I'm going to do this with the other 2 files real quick. Okay, so I have copied over our 3 files that we're going to need. So let's go ahead with this vignere shift. So when we go ahead and use this, so let's go python 3 vignere shift.py, and then we'll specify the file that we want to take all the seconds of letters from. So we'll do /krypton, krypton4, and then our file is krypton5. That's going to be found1 is the one that we want to use. And then we'll specify the key length. So we know the key length is 6. And then we'll specify the shift amount, which is 0. I could also leave this blank for the default. And we'll go ahead and run this. And we can see we get this long string. And what this is if we go ahead and run, actually I won't do that, but this is every 6th letter starting at the first letter of that found1 file. And we know that since the key length is 6, that all of these letters have been mapped through the same letter in the key. So for example, if it was every 4, every of these letters would be mapped through the letter G, which means we're back to a monoalphabetic cipher. So with a monoalphabetic cipher, we can do our frequency analysis. So let's go ahead and do our frequency analysis on this. So python 3 frequency analysis.py, and then our file name. Oh, let's actually save this output to a file. So I'll run this command again. Oops. Python 3 the vignere shift, and we'll save this to let's do found1 underscore shift 0, and we'll save that. So now we have a file with the actual so it's just this output saved into this file. So we can go ahead and do our frequency analysis now. So python 3 frequency analysis.py, and we'll specify our file, which is found1 shift 0, and then our group size, which is going to be 1 because we're just doing the frequency analysis of 1 letter. We don't need to do diagrams or trigrams like we did before. And we see that J is the most common letter. So we know back from our frequency analysis table that E is by far the most used in the English language. So we know that J probably is mapped from E. So let's go back to here. So we know that our plain text is going to be E because we're mapping from E. It's mapped to some key, and our ciphertext is J. So let's go ahead and look at this file here. So J is the 9th letter, starting at A is 0. So J minus E would give us the key. So C minus P equal K. So C is going to be J, which is 9. E is going to be 4. So 9 minus 4 is 5. So at 5 is going to be our first letter in our key, and that's going to be F. So let's go ahead and write down F. So to find the second letter, we just need to shift over again and repeat the process. So let's go ahead and do that. So what I'm going to do is go back to our vignere shift, and I'm gonna call the file shift1, and then we're gonna set our shift amount to, to 1, and then we're gonna get a new file, so let's ls, and now we have this new file here, and we're gonna do the exact same thing that we did before, do frequency analysis, but this time on shift1. And now we see V is the most common. So if V is the most common, we know that V is 21, and then E is, let's see, 4 again. So V, 21 minus 4 is 17, and that's going to map to R. So let's go ahead and add that on. And we're going to repeat this for all 6 characters. So I'll go ahead and do that and come back to you. Okay, so after repeating that for all 6 of the shifts, so we get all the way up to from shift 0 all the way up to shift 5, we get this message here. So this should be our key, F-R-E-K-E-Y, or freaky, or something like that. So now what we need to do is run this through our decoder, and then we should be able to get our plaintext mapped, or our ciphertext mapped into some kind of plaintext. So for that, I have another script, and that's going to be our vignere decoder that I said I would explain later. So what it's going to do is it's going to take two arguments. So it's going to be our file name and then the key. So in this case, we're going to enter free key, and then it's going to take, all it's going to do is it's going to decode it. So it's going to take the ciphertext, it's going to take the index in the alphabet of the ciphertext, subtract the index of the key, and it's going to return that index of our plaintext. You can look through this more again also in my GitHub, but let's go ahead and do our run here. So if we go ahead and look at, so let's do Python 3, and then we're going to do our vignere decoder.py. We're going to specify the file name, which is /Krypton/Krypton4/ and then our file that we want to decode, which is Krypton5, and then we're going to do our key, which is FREKEY. And then there it is. There's decrypting this file with the key free key, and this is going to be the password. And if we remember back, this does sanitize spaces. So if we do cat /Krypton/Krypton4/Krypton5, we do see that there is a space in between here. So our password would be just clear text with a space. So let's go ahead and do clear text, and that should be our password to the next level. So just before we exit out of this, just to see, if they were mixing any tricks in here, we could do Python 3 vignere decoder, and we'll run this decoder on the found one. This has nothing to do with the level, but I'm interested to see what kind of messages they were putting into these found files, if they have any method to madness, and I'm sure they do. Okay, and there we go. So the soldier with the green whiskers led them through the streets of the Emerald City until they reached some room in the Guardian of the Gates. This might be from the Wizard of Oz, but yeah, wicked and fierce. So this is just like a subscript from the Wizard of Oz, or correct me if I'm wrong if it's something else, but encoded with this key, and that's how we were able to deduce what our password for the next one is. So let's go ahead and try that out. So log out. So SSH, let's do our SSH, and then we'll do Krypton5, and let's enter clear text with a space. Oop, maybe not. Maybe it doesn't have a space in it. Nope, no space. Okay, it was doing the blocking of 5, but there's no space. Okay, so there's our password, and level 4 to level 5 solved. So that's how we did the polyalphabetic cipher with a known key length. So when we go into our next episode, it's going to be the same thing, but the key length is unknown, so it gets a little bit tougher. So we'll do that in another episode. I'll see you guys there.